Alright, the next thing is the, whoops, get my pen out here. Well, that's not working too well. There we go. Root test. Basically what that tells us by theorem 13 is that the limit as n goes to infinity of square root, no, the nth root of an is equal to rho, getting better at writing those. And we know that when rho is less than 1, we get convergence. When rho is greater than 1, we get divergence. And when rho is equal to 1, it's inconclusive. We don't really, I mean, it's not a useful test. Okay, so when does this come up? Well, it can come up in a variety of situations. I think the classic situation is when the formula for calculating a sub n includes raising something to the nth power. And I can give you an example. It's from example 3, part A, in which we have the sum from n equals 1 to infinity of the term n squared divided by 2 to the nth. Okay, so there's our something raised to the n power. It might be that you're lucky enough that you have something, you know, raised to the nth power, and then when you take the nth root of it, obviously that just cancels out and you're just left with what's ever in there. This is a little more complex because we've only got this nth power in the denominator. So basically we're going to have to work like this for our limit test of n squared over 2 to the nth. And then we can separate that out into two processes. We take the nth root of the denominator, and we're just going to get 2. We take the nth root of the numerator, and we can think of that as n to the n squared, but we can also rewrite this simply as the nth root of n and then the whole thing squared over 2. However, you know, by our handy rule, we know that that is equal at a limit as n goes to infinity is equal to 1. So this is equal to 1/2, which is equal to our rho, which says that rho is less than 1, therefore this series converges. Okay, let's try a bit of a different example than we've been used to, and we have an, or a sub n here, is equal to, well, when n is odd, okay, it's equal to n divided by 2 to the nth, and when n is even, it's equal to 1 over 2 to the nth. Okay, so now we've got, you know, different rules depending if n is odd or even. And the question is, does this series converge? Well, let's apply kind of simultaneously the root test to both parts of this. Well, the first part we're going to get if we take the square nth root of n over the nth root of 2 to the nth. That's simply going to be equal at a limit as n goes to infinity of 1/2. Okay? And if we look at this and take the nth root of 1, over 2 to the nth, take the nth root of that, that's at a limit that's equal to 1/2. In your book, they represent this a little differently, and they kind of, as a sandwich rule, sandwich this and say that rho is greater than or equal to 1/2 is less than or equal to the nth root of n over 2, like this. But I'm not sure how different that is. In both cases, though, we know that rho is less than 1, therefore we get convergence in this series.